Hello friends, in this video we will talk about Langchain Framework. We will see what are the different components the Langchain provides. It is a complete video about how you can build your GenAI application. Langchain comes with two interfaces with Python and JavaScript. You can use any of them, but in this video we are not going to dive into the interfaces exactly, but the overall architecture, how the different components are organized in Langchain. That will help you to understand overall structure and skeleton through the framework that you can get. If you are a student wants to learn how to program in GenAI code, or if you are an entrepreneur who are trying to fiddle around with GenAI and wants to create some application, this video is for you. So without further ado, let's dive into the magic of Langchain. We will meet after a short intro. So basically a Langchain is a framework and it provides multiple things to create the application for GenAI, and it comes with so many different components. Here we can see Langchain, which provide three parts of it: chain, agent and retrieval strategies. Then there is a community part of the Langchain, and community part is very active in Langchain because it provides plugins for so many things. As you can see, it supports two types of interface in Python and JavaScript. So if you are a Python programmer or JavaScript developer, then you can learn how to code using GenAI applications using Langchain. Here is some code part of Langchain, which is about LCL. We will talk about it further in the video. And the core part basically supports fundamentals of Langchain like parallelization, fallbacks, tracings, batching, the streaming, async, composition. We will talk all about these things. Apart from this, it has few more components. Langsmith, which is a observability tool for GenAI application provided by Langchain. Then Langserve for deploying your chains and your code so that you can use through an API. You don't have to Dockerize it or put in your own servers. And interestingly, Langchain also supports these templates, which basically provide you the basic information and basic structure of the code, which you can use as it is for building your application as quickly as possible. Let's see first the core part of Langchain. In the core part, you can see there is a Langchain expression language. So you might have programmed in some programming language where you can use pipes. Especially in the operating system, you might have used pipes where you will do some operation, then pipe with another operation and then third operation. So the output of this P1 will be input for P2, and similarly output of P2 will be input for P3, and output of P3 will be your final output. On the same basis, Langchain supported pipelines where you can create different pipelines for building your application logic. And what these pipelines contain basically, these contain your prompts, your transformation, anything that you want to do with the prompt and the data which user provided. You can use some retrievals also. We will talk about retrievals during the community part. And the retrieval, it will basically take the data from your databases, and in the output there can be, even before output, there will be some calls to LLMs, where the large language models will provide the brain for your prompt. And these large language models can be of any type. There are multiple models which are supported through the Langchain community. So it's basically, Langchain is not tied to any particular model or any particular framework. Itself provides so many different components, and it's a pluggable architecture where you can use whatever you want to complete your application. But fundamentally, to build an application, there are multiple things at the fundamental level is required, and which basically Langchain supports is parallelization. So consider a use case where you want to talk to LLM multiple times. For example, if you are using COT, chain of thought, then your prompt will be querying across multiple perspective through the LLM. And if you do this in sequential, then there will be more time delay, right? So if your application is targeting to reduce the latency, then this parallelization can be easily done without much efforts from your part, but the framework will take care of it. Similarly, for some error boundaries or any kind of fallbacks, in case of any error, you can deal such cases through the fallback part of the Langchain. In tracing, no application is complete or can be put to deployment if there is no tracing. It's important to identify what the user is doing and see how your application is performing on the user's query. So tracing is important for debuggability, which is out of the box provided by Langchain. And then batching. So for example, if you want to call multiple LLM, so for example, if you want to have multiple calls to the LLM for different tasks, then you can batch together. Instead on a separate query that you are firing to LLMs, you can batch it together and provide to the LLM. Then LLM in one shot, it can return all the data. So what you can do, you can provide, let's say, a list of your prompts, right? And those lists, and in your instruction at the base level, you provide, okay, these are the things that you have to do with these prompts, prompt 1, prompt 2 and prompt 3. And LLM will provide the response together for all these 3 things. And then based on your use case, either you can further pre-process these 3 and perform the user section, whatever user has requested. Streaming is another important feature of Langchain. So there are some use cases where you have to get the response, even the partial response, as soon as possible it is available. So this can be easily done through streaming. And when you have written your application using the LCL, so in that case you don't have to worry about which particular type of communication that you are using with LLMs. With only one change, you can do either batching, or you can stream, or even you can do async operations, where you don't have to wait for the response from the LLM because it is time taking. You can take that response and handle asynchronously. So this is important to in latency related application, where you can keep responding to the user request that your request is in process, so that user will have something in their interface. And composition is all about how you are creating your prompts using multiple things to build up a prompt. So like you can use few short prompts where you will provide some examples, few examples basically, for the LLM to understand that use case and then respond accordingly. That is very helpful technique when we are doing the prompt engineering. It helps in providing the right answer, and also it helps to reduce the hallucination, which is a very important topic in Langchain or LLMs, basically not Langchain, because all LLMs are prone to hallucination, and this is very important when you are dealing with some critical application where hallucination may ruin the use cases. Now let's talk about Langchain chains, agent and retrieval strategies. These are cognitive part of Langchain. Chain is basically your chain which we are creating to process your prompts and to process the whole use case basically, because some of the part of the chain can be prompt, some of the part can be retrieval from some vector database, other can be calling to LLMs, and then some other parts of the chain can be parsing this output so that you can do some further processing, or you can do return the data as per the required format to the user. And similarly the agent. So to understand the agent, consider LLMs as the brain which provides the logic, because it understands the language. So whatever you have provided input to the LLM as text, it can understand the semantic part of it, but it doesn't know there are few incapabilities which LLMs cannot do. For example, mathematical calculations very nicely it can't do. Hallucination is one of the main problem with LLMs. So to deal with such cases or some specific use cases where you have some proprietary information which is not available to the LLM, and some real-time information which LLM is not made for, then such information can be fed to the LLM and this brain basically using the tools and the agent. So agent will act as deciding factor. Agent will try to understand your user's query and try to decipher what are the different things that can be done, and then it can provide the tools information to LLM. So agents will call LLM, but LLM results will be returned to agent and it will see which particular path has to be chosen, and accordingly it will execute that path. Now there can be multiple tools. For example, you are building an application which require latest data for weather forecast for a city. Then in that case, LLMs is not right place which knows this information. There may be some APIs provided by some source. Then you can use those APIs and provide to LLMs. So the LLM will use this information to get the real-time data of the weather in a particular city. So this can be one tool, and the tool can be, let's say, which can perform some mathematical calculations, right? So those things can be done, and other tools can be your APIs which you are creating or any specific information that you want to provide. So there can be multiple tools, and agent will act as a deciding factor which will see which particular path has to be chosen, and LLMs will act as a brain where it will actually execute different things and provide the options to the agent. So this is a very important technique when you are building some complex application using the Langchain or in the GenAI space. So consider LLMs as a tool which is enabled by these companies which are building and providing APIs for LLMs, and you can build on top of it for some use case. And if you are thinking of building something like this, then agent is your friend, where it will solve many problems of yours, proprietary information and any real-time data which is required for your application. Now let's talk about retrieval strategies. What this means? You need to retrieve some data as a proprietary information or through some APIs, right? Or through some PDFs. All that can be done through retrieval strategies. So Langchain provide multiple types of retrievals through which you can do, and you can see in the community, and it is a pluggable architecture, so anyone can build their own retrievals if required and can enrich the open source code of the Langchain. So here the retrieval is these things. So retrieval for the data document loader. So you already have, let's say, some PDF or some Word doc or in any other format. You can load that data so that that particular things can be used in your app. And in vector store, so vector store are databases which store vectors. After converting your data to vectors in a n-dimensional space, which is provided by your embedding models that you can use. I have another video about vector stores and vectors, how they look like, and what type of vector databases are available. I will put the link of that video in the description. So please check it out. It is a in-depth video about vector store and the text splitter. So this is the first thing. Let's say you have some PDF document, right? And that will have a lot of text. You can't build the whole, put the whole data, your PDF in a database in one shot, right? You have to split it in smaller things so that when you retrieve, you will get only the relevant part of it. So consider an example. There is a report, let's say some R&D organization has published, let's say some about the market scenarios in US. Then in that case, you want the data for some particular city, right? If you provide the whole data, whole this report as a context, then it may be too much, and there will be too many tokens that will be used when you are passing this whole information to the LLM for processing. But that is costly and not effective. So the better approach will be to chunk it in a smaller pieces and store in your database and vectorize those things. So whenever you have a new query, right, you can convert the query into a vector and check for similarity search if it is there any similar vectors which is available. So from this DB, you are pulling only the relevant information and then passing this query and plus the retrieved documents to the LLM. Now in this way you have the less vectors, less tokens basically. Plus this will be more effective to answer. And embedding models is all about how we are creating a query into a vector, right? So that is done through a model. I have explained about the models also in a video of vector store, because here we have to create vectors through some embedding models. So you can check out this video, vector store related video. Let's see about model IO. So here, and these are like integrations which community has done with different things. So the models can be of OpenAI ChatGPT model, or Google's Gemini models, or IBM's Cohere model, or any other model, or even you can host your own model, or your custom trained model will be more cheaper, and also you will be controlling it more for your use cases. So Langchain as a framework provides support for a model, and you have to just put the model, your model name, and your model will work, instead of changing your whole code a lot if you want to try out different models. Similarly, there are different prompts techniques. As you might be knowing about prompt engineering. Soon I will create a video of prompt engineering, and I will put the link of that video in the description of this, so that you can learn different prompt techniques which are emerging. And because of this, like, there are multiple ways that you can create your prompts depending on use cases. So Langchain provide multiple ways, and you can use one of your ways which suits your application. And similarly, example selectors. So if you want to select some particular prompt that you can check. So community has provided these supports. Langchain basically is a pluggable architecture where different things can be done. Similarly, the output parser for the final phase of your output, or intermediate phase between the two sub phases. So output parser is when you got the output from LLM, you can parse it in particular format. For example, you can convert it to JSON format so that you can use it in further pre-processing, or you can return the data, the relevant sections to the users through your APIs. And you can also check how many tokens are used in this particular query, so that you can track the usage of your users for your application. So model UI is an important part of Langchain community, and agent in tooling I have already explained in the agent section, right? So there are tools and toolkits. So tools are basically the specific tools which can be used by LLMs through the descriptions. You pass the description of the tools to the LLM, and then LLM will say, okay, this tool fits well, and then that agent will call that particular tool for the user. It can be an API call, or it can be execution of the code like Python, RPL, right? And then toolkit is basically combining multiple tools. So instead of one tool, you can have a number of tools, right? And for any particular use case, one of these tools will be used. And now which particular tool to be used, that will be decided by LLM. And who will call that particular tool, which is agent, right? So this is how the architecture looks like. Now let's talk about important things in now let's talk about some other aspects which Langchain provide. So let's talk about template first. So in the template, it has a reference application. So some of the applications have the specific patterns, right, that you have to put. It is just like the design pattern you might have read while building your software skills. So there are design patterns which are tested way or to solve some particular problem in particular form. So templates try to fill that gap, and that functionality you can use through templates. In the reference application, Langchain provide multiple apps. For example, there are some application which uses RAG, and there are some application which uses reflection, right? And this is a pattern, basically one of the pattern which is emerging when we are building the application using the Langchain for the GenAI apps. And others like can be like reflection. I will create a videos on these different techniques later, and you can subscribe to my channel so that you can get notified when such videos comes up. So these templates you can use, and you can kickstart your app quickly. So these are ready-made basically code snippets which can use faster building your app. And the LangServe is for deployment solution provided by Langchain. So let's say you build your code, right? Now you want to serve that your logic through some app. So now what you can do, if you are using Python, then you can put a Flask app, right? And then run your code. Or if you are using, let's say, some JavaScript, then you can use Node.js based framework, right? But you have to build and manage all these things. So instead of managing yourself all these things, you can use LangServe, which is a paid solution provided by Langchain, where your API, your code will be served through API, and you can use those APIs, and you will pay only for the usage, the number of times that you call that a particular API. So this is a faster way to build prototypes. Instead of focusing on the deployment and all, you can build and check your GenAI idea or your application, how it performs, right? And later on, if the load increases, then you can think of about hosting on yourself through some framework using Flask or Node.js or any other like fast API or anything, right? Django and all. And then you have to deploy. So basically it can be containerized environment, right? You can run in a container form in Kubernetes, or if you're using AWS, then ECS, or there are multiple solutions for container based like Fargate, ECS, managed containers, or you can use the specific Lambda serverless form. So that is up to you, right? Okay, and then the final part is Langsmith, which is an observability platform for building the application. Now with Langchain, for any GenAI what is the main problem? That you put up the code, right? You create your prompts and you hosted this, and your clients are calling this API and doing their own workflows, but you don't know how that particular app is performing, whether the response which is generated by the your app are good enough, or how they are rating, or is there any change which is happening, because the language models, right, which you are using can be updated, or your prompts that you are doing in another version when you are modifying that code, you don't know, or how will you monitor your code that your apps are producing better results, or it is diminished the quality. So to do all those things, Langsmith is a solution provided by Langchain. You can build your apps and see how it is performing, and you don't have to put every query as one prompt and see the response. You can have multiple other list of the prompts, and then you can see the results and you can score them if it is performing well, and in multiple versions in v1 v2 of your apps you can compare all these things, right? And when you are building, you have to debug in the different phases of your chain how the output from each part of the chain occurs, right? So that can be done through Langsmith, where you can monitor the output of each phase of your chain. Also, when you have put in the production, you can see how the users are getting the responses, if there is any change or drift from your model. So for example, if you have hosted your own model, or you have changed the model which is provided by some of the companies, like let's say OpenAI, there is a new model from ChatGPT 3 to ChatGPT 4, right? You moved, or you move from ChatGPT to Gemini of Google's, right? So you don't know how the things are moving, but through Langsmith you can compare the responses, and you can see is there any way that your models are getting, your responses are getting drifted from the original that you have planned and provided in the previous versions. And one of the main problem which you might be knowing about hallucination for LLMs, that can be tested and evaluated through Langsmith. I mean, it provides some weights, right, through which you can see the confidence level of that particular responses. So if the confidence of the response is good, then you can consider that there is no hallucination. Or if there is a confidence, let's say reduced through a threshold, let's say 40%, then you might say to the user that you can't provide the results because you don't want to hallucinate and take that risk. So that's it for the Langchain architecture and Langchain overall component that provided by the Langchain. So I hope you like the video, you have understood about the different parts that Langchain provides, and it is a very great platform which is emerging for GenAI application. So if you have any question, please let me know in the comment section. I will be more than happy to answer those questions. And if you have any suggestions, please feel free to put that too in the comment section. I'll be more than happy to incorporate in the future videos, and that will help me to improve as well. So if you like this video, please share with your friends and in your community, and click on the like button so that this video can reach to some other potential students who require the knowledge of this. Please subscribe this channel. That will also an indicator for me that I am on the right track to build such content. Thank you. With this note, I'll take a leave. This is BK from Maneka signing off.